Hey everybody, Dr. Nelson here. This is a video about something called a perfect square. So you're going to take some notes with me, and then you have a chance to try some problems on your own, and then at the end you can see how you did. Alright? So you should already be familiar with some square numbers. Like for example, the number 4 is square because 2 times 2 gives us 4. The number 100 is a square number because 10 times 10 gives us 100. The number 25 is a square number because 5 times 5 gives us 25. Another example would be, say, 81 because 9 times 9 gives us 81. So a perfect square is an expression that can be expressed as the product of two equal factors. Alright? So here's a question for you. Look at this trinomial. 4x squared plus 12x plus 9. And I want to know if I factored it, okay, would it make this a perfect square? So what I've done is I created kind of like a three-step process to determine if this trinomial is a perfect square. And this is what you do. It says the first question is the first term a square? Well, the first term here is 4x squared. And I know for a fact that that is a square because 2x times 2x gives us 4x squared. So I'm going to write 2x here and check. So the first term is a square. Step 2, is the last term a square? Well, our last term is a 9. And I know that 3 times 3 gives us 9. So absolutely, that second part is true also. Now, step 3, it says ignoring the sign is the middle term twice the product of both terms. Let me say that again. Is the middle term, so in this case, a 12x, ignoring the sign is the middle term twice the product of both terms. Well, 2x times 2x times 3 gives us 6x. And if I multiply that times 2, we get 12x. And that's what that is, right? So guess what? That means this right here is a perfect square. And we're going to factor these pretty soon. All right, the second one. We have 25x squared plus 13xy plus 4y squared. So step 1, is the first term a square? And the answer is yes, because that's going to be 5x. Part 2, is the last term a square? Well, 4y squared is a square, so it's going to be a 2y. Part 3, it says ignoring the sign is the middle term, so in this case, a 13xy, is the middle term twice the product of both terms. Well, 5x times 2y is 10xy. And if I double that, we would get 20xy. And if you notice, this right here is not a 20xy, which means this whole thing is not a perfect square. All right? So trust me, after a while, you're going to look at terms, and you'll be able to do this kind of in your head. But what I want you to do is I want you to pause the video and try the next problems on the next page. And then when you're done, hit play. You can see how you did. All right, good luck. All right, welcome back. Let's say you did with these practice problems, okay? So for each one of these expressions, we want to know, are they examples of perfect squares? So step 1 is you had to first determine if the first term is a square. So 4x squared, we know that one is. That's going to be a 2x. Step 2 is the last term a square. So here, well, 1 is a square number because 1 times 1 is 1. So we're going to have a 1 there. And then step 3, ignoring the sign, is the middle term twice the product of both this and this. Well, 2x times 1 is 2x. And 2x times 2 gives us 4x. And again, we're ignoring that sign. And so we have a 4x. So that is a yes. So this right here, we could say yes is a perfect square. All right, the next one, 16x squared plus 24x plus 11. Well, part 1, is this a perfect square? And the answer is yes, because that's 4x. Part 2, is this a perfect square? And the answer is no. All right, the square root of 11, okay, is not a whole number. So we can actually stop there. This whole expression is not going to be a perfect square. All right, the last one, x squared plus 18x plus 81. Part 1, x squared is a square number. Part 2, the last term is a square number, that's a 9. Part 3, when I multiply these together, 9 times x is 9x, and when I double it, I get 18x, and that's what this is. So we know that this expression, x squared plus 18x plus 81, is a perfect square.